Hello everyone, I am back with yet another 3D printed muzzle-loading Nerf blaster, and it is my biggest yet by quite a margin. And if you want your own, all you need is access to a 3D printer, a small pile of metric screws and hex nuts, about 7 little springs, and a bunch of elastic bands. A quick reminder that the files for these are linked in the video description if you want your own, and if you don't have your own printer, I've also linked some production partners as well who may be able to help you out. So what the heck is this? Back when people used muskets, the only way to shoot faster than you could load was to carry more than one musket. One alternative that was tried regularly from the invention of black powder right up to the Napoleonic War was to just glue a bunch of muskets together. So this takes the most tactical, mole ninja idea of the muzzle-loading era and has turned it into a toy you can use to absolutely ruin a children's birthday party or reenactment group meet. Engineering-wise, this is a complete rebuild compared to my previous work. In particular, because it weighs so much, this is just over 2 kilograms, most of which is plastic weight, it is very awkward to move without accidentally bumping it into things, so this has a lot more strength up front and at the back. That said, it still uses the rubber band mechanism I've shown in my other blasters, which saves you having to build 7 individually loaded plunger tubes. Most other Nerf shotguns put a bunch of projectiles, darts or bowls, in front of one air chamber, which limits how much power you can get out of it. At least this way, each one of these barrels should get you somewhere between 80 and 90 FPS at the same time. You can see that's hitting somewhere between 15 and 20 meters away without too much difficulty. Importantly, all the darts and bowls are getting about that far. It does seem to perform a little better with the darts, but the bowls are more fun. Like my other designs, there's also a decorative flintlock mechanism. It's a little floppier than my previous ones. May change that in future ones. You can back it up with a pet G spring or a real metal spring if you really want a bit more oomph out of that. Just a little reminder how this is going to work. So, take the ramrod, you prime it, insert a dart or rival bowl, give that a bit of a push. Now, the diameter in there is just small enough to ensure that a rival bowl, once pushed in, won't flip back out. You can then repeat this for all the barrels, but it'll fire with just one as well. Now you'll note that was a very smooth, quick trigger pull. But one slight issue with this is when you've got all 7 catches activated, for example, what you'll tend to find is that this has a really heavy trigger pull. It works, just something worth highlighting. So, with that said, let's take this apart and show you how it works. I'm pretty proud of it. First off, let's maybe get some insight into how we're setting off all these barrels at the same time. I'm gonna take off this lock plate. As you can see, this is very similar to the mechanism I use in my other flintlock blasters. The exception, the spring has had to have this crystal around here because that area is occupied by the barrel. You can see more detail for that in the instruction video. And if you're desperate for a bit more oomph, you can start gluing springs between those contact points. The trigger is just moving this big sort of plunger-shaped sear back and forth. You can see just a hint of the catch in there, which are arranged in a radius around here, with each their own individual spring. What about the rubber bands? Let's have a look at that. So, you'll see with some other 3D printed blaster designs, there'll be a big steel rod all the way through for strength. With this, I wanted to keep things simple, and just the sheer mass of plastic made it a tad unnecessary. So instead, everything is held together with these connecting plates, which, if you want to get at the part, you'll probably need some access to every now and then. See, there's these little orange dovetails, which get out like so. So we have here the front half of the assembly. This is more or less decorative, it will work without it, but it does give you a place to hold your ramrod and a place to hold the rival bowls. Put that aside. Then, once we have these dovetails off, you can see the monstrosity that is how this works. So I won't take it off all the way. You can look at the assembly video for a little more detail on that. But essentially, 7 independent rubber band barrels here that are all locked and shot individually. You will eventually have to replace the rubber bands, whatever elastic you are using in here. Although, as I've shown in my previous videos, you can probably get close to 100 shots without having to worry too much about that. Given how long this takes to reload, I'll be impressed if you need to do this often. So, let's put this back in. And chuck this guy back on. Okay, I think that's everything. Obviously, this project was a lot of fun to do. I love making this stuff. That said, maybe on a hiatus for a little while. I've had this project complete for months and just haven't had the time to put together the instructions, which, by the way, are linked in the video description. You'll need at least a Prusa Mach-free or Ender-free size printer to build this. Anyhow, thanks for your continued support. Subscribe, buy my crap. There's a Discord. Sometimes I check it, but people have loads of built-in advice on there. Anyway, have a good one.